This is going to be our final project video, and for the final project we are going to change to report the position of the robot using the IMU, the IR sensor, and the encoder. In this video I'm going to show that the encoder is working fine, and the motor it can drive it, and I can use PID to make it drive accurate. And the IMU is not working, but I have showed that I try my best to make it work, and I'm going to download some filter to make it work better.
In order to get the robot to move, we had to have the node that makes the motors move subscribe to the RQT. The RQT then the RQT sends out the velocities to that node so that it can move forward and backwards. Here we're going to do this ROS run and the ROS launch, and we're going to open up RQT in order to send the robot the velocity commands that are being received by the node, the motor node. Then here we increased the velocity, and the robot can also turn.
I'm going to show how the encoder works. First I do sudo bash and I get the permission, and I use rosrun control encoder.py. It's my encoder node which uh, uh, published the join state message of 4 wheels, and I run it, and it start give data, and I can use RQT to visualize it. Here's I open RQT. And you can see that the time is moving, and if I just move the wheel, you can see data is actually moving in the inverse direction. And if I move this back in a forward direction, you can see the data is changing. And I have opened a new terminal. I can do ROS list, and if I look at the TF this channel, this topic is going to use my data from the encoder, and it's going to give the position of the robot, and I will show that. But it's now currently doesn't working, and I don't know why, but I'm working on it right now. Topic echo. So I think it's getting some data, but I don't know why it doesn't work right now. So I'm supposed to be able to visualize this in Arvis, and if I open Arvis, open always and add if I add the TF one and add it and frames. If you only show the base link, my move it's supposed to work, but currently because of the TF, there's something wrong with it, so I can't move it right now. And for the IMU, I'm going to show how the IMU works first. I need to get to my workspace. This is heading. The heading of IMU means that how much I turn. So my turn, you can see that it's quite accurate because it gives some data and it's accurate. But for the it's using the magnetic field. But if I change it a little bit, so you can see this is my code, and all my code can be seen on GitHub in that repo. If I make it to show the distance, which I use a dimple second differentiate to calculate it, it's not going to be very accurate. It will be very noisy. Although I make it to spin 1,000 pairs right here, it's still not very accurate. You can see data gates. Yes, I move around, but you can see that data changing when I move around. It increasing very fast, but it's really inaccurate, and I'm trying to figure out why it works like that. And maybe for the project in the future, I might going to download a more accurate annual filter to work to get more accurate data. I'm going to show that we can control the PID, but since the robot is moving quite smooth and being quite accurate, so from now I don't see that we need to change the PID. Maybe in the future, when we complete the IMU and get more accurate positions, we might need to use the PID control, but now we do not need to use it. But I'll show you that we can do that. Plugin. And we're going to configurations and the net make free. If I expand this, you can see that this is the 4 topics that my encoder node have given, and we can change all this. But things is working quite well, so I don't see that we need to do this, but we can do this if we need in the future. So I will show you how to use the IR node. So first, you need the sudo bash to get the authorized and run control IR node py.
Then you can see the frame ID and the max range and minimum range, and we set the 1.5 as our data we need between maximum and minimum. Now I will show it in the RVs to visualize the sensor reading. The range is between 15 cm to 1 meter.